Hello, and today we're going to be looking at factoring problems using the distributive property and factoring in general. First off, prime polynomial. Remember, most polynomials we run into are going to be called prime. That is, it's a polynomial that in its form can't be factored, either by using what we know about two binomials or finding the common denominator. It doesn't have any common denominator. It's kind of like two numbers are relatively prime if they don't have any common factors other than 1, because remember, 1 goes into everything. Now, if we take a look at here, I want to factor out the greatest common factor in this binomial. Well, if I look at these two terms, 33 and 121, 11 goes in both of them because the greatest common factor between 33 and 121 is 11. Now, what goes into both x to the 5th and x squared? It's x squared. So I'm looking for the biggest algebraic term that goes into both x squared and x to the 5th. Well, x to the 5th doesn't go into x squared, but x to the squared goes into x to the 5th. So if you have two common variables and they both go into both terms, you always pick the one with the smaller exponent because the smaller exponent has to go into both of them. Then I factor that 11x squared out, which is actually kind of like the opposite of multiplying here. 11 times what is 33? Well, that's 3. X squared times what is x to the 3rd? So x squared times x to the 3rd is x to the 5th. Minus 11 times what is 121? Well, that's 11. I already have the x squared, so x squared times 1, but I'm not going to write the 1 there, so I get 3x cubed minus 11. Now, does 3x cubed minus 11 factor? No, nothing goes into both terms. I can't multiply two binomials that have integer coefficients that will give me this answer, so I'm done factoring that problem. Now, if I take a look at, I want to see if I can factor this polynomial completely. So if I take a look at question 2 here, notice 4 goes into both of them, so I get x squared plus 9. Can I factor x squared plus 9? Well, the only way I can factor a binomial is if it is the difference of squares, but notice this is the sum of squares, so no. Can I factor this or state whether this polynomial is factored completely? Yes, it is. Factor completely. Now, if I take a look at question 3, unlike question 2, notice this is a difference of squares, so no, this is not factored completely because I can factor x squared to x plus 3 times x minus 3. And there you go. Okay, now let's take a look at number 4. I want to factor these completely. First thing I look at, I try to look for a common factor. Notice what goes into both 5, 25, and 30. Well, 5 does. I've got x squared, x cubed, x squared, x. X goes in everything, but nothing else bigger goes into it now. Let's factor this out. 5x times what is 5x cubed? Well, that'll be x squared. Minus 5 times 5 is 25. I'm missing an x because x times x is x squared. Minus 5 times what is 30? Well, that's 6. Already got the x. Now, can I factor x squared minus 5x minus 6? Sure, I can. Notice as a common, the leading coefficient is 1, so I can do this as a diamond problem. So negative 6, negative 5. What two numbers multiplied to negative 6 and added negative 5? Well, that would be a positive, let me see here, where's my eraser? That would be a negative 6 and a positive 1. Because negative 6 plus 1 is negative 5, negative 6 times 1 is negative 6, so this factors to x minus 6, x plus 1. There we go. Now let's take a look at the next one. 75x to the 4th minus 3x squared. Well, what goes into both 75 and 3? Well, 3 does. X squared. So 3 times what is 75? Well, that's 25. X squared times what is x to the 4th? Well, that's x squared. Minus 3 times what is 3? That's 1. But you got the x squared, so minus 1. Notice this parentheses is a difference of squares, so that becomes 3x squared times 5x plus 1 times 5x minus 1. And there we are. We're done with that question. Okay, now let's factor number 7 completely. This one's a little bit different. Notice there are 4 terms. So here's what I'm going to do. I'm going to factor 2 terms at a time. First of all, I've looked. Does anything go in all 4 terms? No, it doesn't. So I'm going to factor x squared plus 4x. Then I'm going to turn around and I'm going to factor 6x plus 24. Anytime you have 4 terms, you might want to think of it that way. Now, if I look at just x squared or x cubed plus 4x squared, well, x squared goes into both of those. So then I'll have x, because I already got the x squared part of x cubed, plus 4. And then I go and I factor what goes into both 6x and 24. 6 does, and I've got x plus 4. Now this is a common factor, because in the first term, x squared times x plus 4 plus 6 times x plus 4, the binomials are the common factor. So just like I factored out an x squared out of the first 2 terms, or a 6 out of the next 2 terms, because 6 went into both of them, well, x plus 4 goes into both these terms, so I factor the x plus 4 out. That goes out in front. And then what I have left over inside the second parentheses, well, in the first term, I've got x squared left over. The second term, I've got 6 left over. I can't factor x squared plus 6, so I'm done with this problem. So it's x plus 4 times x squared plus 6. Important key about this one is break it down into 2 terms at a time. Now if I take a look at number 8, I'm going to pretty much do the same thing, except there's one little thing I'm going to make it a little bit easier for you, a hint I want you to look at. Once again, I'm going to look at just the first 2 terms, and then I'm going to look at just the last 2 terms. And so when I take a look at just the first 2 terms, x squared goes into both of those. And then, so x squared times what is x cubed? Well, that's x plus 2. Now here's what I'm going to do in the second 2. Yes, 36 goes into both of these, but since I want the leading coefficient in my, when I factor it out in my parentheses to be positive, rather anytime I have a negative as my leading coefficient of the second term, I'm going to factor out a negative. So minus 36, well, that will be negative 36 times what is 36? Well, is a negative 36, so that'll be a positive x plus 2. Oh, and look at that. The x plus 2's are the same in both terms. So I can factor out the x plus 2. And then what's left over, x squared minus 36. Well, notice x squared minus 36, that is a difference of squares. So that becomes x plus 2 times x plus 6 times x minus 6. And there's your answer for that question. Now, if I take a look at the next problem I'm going to show you is a different way to factor trinomials with a leading coefficient, because we've kind of struggled with this. And there's a math teacher, a very good math teacher in Macintosh named Bob Schue. He kind of came up with this as a way to help his students who are struggling factoring with a leading coefficient. So here's what you're going to do. If I'm given a problem that can be factored, a trinomial that has a leading coefficient that can be factored, the first thing we're going to do is we're going to write down the problem, of course, and then I'm going to write down the first and last term. So if I take a look here on example 10, we will do example 10 with using the Bob Schue method and show you how we can do that. And of course, we always look for the common factor, but there is no common factor. So I write down 6b squared, and then I write down the last term, which is negative 2. Then, second step, multiply the first and last terms. And use that in your diamond. And so what he's really saying is this. If I multiply 6 times negative 2, I'm going to say multiplies to negative 12. That's the way we can come up with what two numbers how do I get negative 11 from my outside and inside? Well, he says multiply the first and last, and then use those. Well, what two numbers multiply to negative 12 and add to a negative 11? Well, that would be negative 12 and a positive 1. So the way I get negative 11b, I'm really just rewriting the problem. I'm not doing anything different. So I'm going to say negative 12b plus 1b. Then, next step, we're going to factor by grouping. Since we have two terms, so I'm going to look at just my first two terms and say, what goes, by the way, could have I said 1b minus 12b? Sure, I could have. That's not going to change how we do it. So I look at just the first two terms. I look at the last two terms. And so now what we're going to do is what goes in both 6b squared and 12b? Well, 6b does. That's a 6. My handwriting is kind of bad, so I'll change that so it looks a little bit nicer. 6b. So if I factor out a 6b, 6b times what is 6b squared? Well, that's b. Minus 6b times what is 12b? That's 2. Now if I look at the next two terms, that's a prime, isn't it? Nothing goes into both of those. Well, what goes into every pair of numbers? 1 does. So I'll write 1 parentheses b minus 2. Now notice, factoring by grouping, the binomials are the same. So I can factor that binomial out and write that in front. So b minus 2 times parentheses 6b plus 1. And that's all I do. 3 steps to doing the Bob Schue method. So if you've been struggling when you got a leading coefficient, you might want to try this method. So let's do that with number 11. I write down the first term. I write down the last term. I multiply the first and last. In this case, it would be negative 10. What two numbers multiply to negative 10 and add to negative 9? Well, that would be negative 10 and a positive 1. Well, boy, we've been kind of lucky here with the numbers that I picked as an example. So 10, so 5w squared. So I'm going to, instead of writing negative 9w, I'm going to say negative 10w plus 1. By the way, I find it easier if you write the negative first. If you have a positive and a negative, if you have two negatives, you can't get around that. And of course, you have two positives, it really doesn't matter. So now I factor by grouping. Look at the first two terms. Look at the last two terms. By the way, I didn't write my w there. And so now, what goes in both 5w squared and 10w? Well, 5w does. 5w times what is 5w squared? Well, w is. 5w times what is 10w? Well, that'd be minus 2. Plus, nothing goes into both of those, so I'll write 1 parentheses w minus 2. And once again, notice when I do this correctly, the binomials are the same, so I factor out that whole term. In this case, the term is a binomial. It's a common factor in both of these. So w minus 2 times 5w plus 1. In case you're wondering, hey, does this really work? Well, let's FOIL it to check it. Let's use the distributive property. W times 5w is 5w squared. W times 1 is a positive w. Negative 2 times 5w is negative 10w. Negative 2 times 1 is negative 2, and I get 5w squared minus 9w minus 2. Notice that's exactly what I started with. There's my answers. And that's all I have to do on those. Now if I look at the next one, just solving an equation. And we're going to do the same thing. What goes into both 16x cubed and 100x? Well, 4 goes into 16, and 4 goes into 100. So 4, I'm going to factor out the 4x. 4x times what is 16x to the third? Well, that would be 4x squared minus 25 equals 0. Notice 4x squared minus 25, that's a difference of 2 squares. So that'll be 4x times 2x plus 5 times 2x minus 5. Now I'm going to apply the zero product property. It says when I multiply three terms and they equal 0, at least one of those must be 0. That is 4x equals 0, or 2x plus 5 equals 0, or 2x minus 5 equals 0. So then I'm going to divide both sides by 4. So x equals 0 in the first case. In the second case, I'm going to subtract 5 from both sides. So then I'll get 2x equals negative 5. So then I'll end up dividing both sides by 2 here. So x equals negative 5 over 2. Then I'll do the same thing in the last part. In the last equation, this time I'll add 5 to both sides. So 2x equals 5. Divide both sides by 2. X equals 5 halves. So I have three answers. X equals 0. X equals negative 5 halves. X equals positive 5 halves. Now if I take a look at number 14, I want to solve this one. And once again, I look at what goes in all three of these. Oh, 2x does. So I'm going to factor out the 2x. Well, 2x times what is 2x to the third? Well, it'll be x squared. Minus 2x times what is 10? Well, that'll be 5x plus 2x times what is 8x? That'll be 4 equals 0. Then I do my factor, and I'm going to go x and x. Since I have my leading coefficient is 1, I'm looking for two numbers that multiply to 4 and add to a negative 5. Well, that'll be negative 4 times the negative 1 is a positive 4. Negative 4 plus the negative 1 is a negative 5. So I'll say x minus 4, x minus 1 equals 0. I have three factors here, and I'm going to see which one could be 0. So 2x equals 0, or x minus 4 equals 0, or x minus 1 equals 0. In the first case, if 2x equals 0, use mental math. 2 times what is 0? Well, x is 0. In the next case, let's use mental math there. X minus 4 equals 0. What number minus 4 is 0? X equals 4. Finally, what number minus 1 equals 0? X equals 1. So I have three answers. X equals 0, x equals 4, or x equals 1. And that's how we do that question. Now if I take a look at question 15, we got this example. It says the width of a box is 2 inches less than its length. The height of the box is 8 inches greater than the length. The box has a volume of 96 cubic inches. What are the dimensions of the box? Well, let's draw a picture here. So I've got some sort of box. What you call length, width, and height really doesn't matter. But everything is based on the length, isn't it? So I'm going to call the length of the box x, because everything else is based on. The width of the box is 2 inches less than that, so I'm going to call that x minus 2. And then the height of the box is 8 inches greater than the length, so I'll say that's x plus 8. So now what I want to do is I want to find the volume. Well, remember, volume equals length times width times height. So what I'm going to do here is I'm going to say 96 equals length, which is x, times width, which is x minus 2, times height, which is x plus 8. So I want to solve this. Now, remember, to solve it, it's got to equal 0. And so I'm going to say subtract 96 from both sides. So minus 96 from both sides. So then I'll get 0 equals x times x minus 2 times x plus 8 or minus 96. Now that's not a polynomial as I can think of it, because it's not in factored form, because I got it in factored form, everything's multiplying. So let's multiply everything together. So if I distribute the x's inside the first parenthesis, I get x squared minus 2x times x plus 8 minus 96. So let's distribute again. So then I'll get 0 equals x squared plus 8x squared. Well, let's try that again. I said that wrong. So 0 equals x to the third plus 8x squared minus 2x squared minus 16x minus 96. I got 1, 2, 3, 4, 5 different terms here. So what I'm going to try to do is I'm going to try to break this down. And I don't know if this is going to work or not, but let's try to break it down into a binomial and a trinomial. So I'll take a look at the first two terms squared, and I'll take a look at the last three terms and see how that works out. Well, if I look at the first two terms, x cubed times plus 8x squared, the common denominator there will be x squared. If I take out an x squared, I'll have x plus 8. Over here in these last two terms, I notice negative 2 goes in all of them. So I'll factor out a negative 2, and I'll have x squared plus 8x plus 48. Now, that doesn't factor, does it? Because I don't have two numbers that multiply to 48 and add to 8. Because I run into a problem there, is because all the factors for 48 are going to be too big. So that's not going to work. Well, let me try this. Let's go back and let's do the first three terms and the last two terms and see what I get there. I don't know if that's going to work or not, but let's see what happens. And do I have an eraser here? Let's see if I don't know if this is going to erase. Okay, I'm going to look at just the first three terms and the last two terms. So if I look at the first three terms, what goes into all of those? Oh my goodness, this wasn't even simplified, was it? That's why it didn't work. So x cubed plus 6x squared, I didn't notice that, hey, that I could have combined those, minus 16x minus 96. Now, let's take a look at the first two terms and the last two terms and see if I can do it a little bit better this time. So what goes into both of these? Well, x squared does just like before, except now it's x plus 6 minus, does 16 go into 96? Sure it does. 6 times. So I'm going to factor out a negative 16, and I'll get x plus 6. And now notice that x plus 6 goes into both these terms. And then I get, if I factor the x plus 6 out, I've got x squared minus 16. And this factors, remember this, all of this is equal to 0. So x plus 6, that's x plus 4, x minus 4. So let's use some mental math here. So x equals a negative 6, or a negative 4, or a positive 4. Since x is length, I'm going to reject negative numbers because I can't have negative numbers for the length of my box. So the length of my box, the length is x, or 6. What did we say it was? Length is 4. The width is minus 2, so 6 minus 2, well, 4 minus 2. Man, why do I keep on thinking of 6? 4 minus 2 is 2. And the height is plus 8, so 4 plus 8 is 12. Now, 4 2, 12. Do I get 96? Sure, if I multiply length times width times height, I get 96. That was a fun problem. It's fun because I didn't notice I had like terms there. It would have made the problem a lot shorter when I was doing this problem. Next, let's solve this equation. Negative 60x to the fourth plus 114x cubed minus 36x squared. Well, the first thing I noticed, 60 and 36, 6 goes into both of those. Does 6 go into 114? If I take 114 divided by 6, it gives me 19. That seems like a pretty good guess. And since my leading coefficient is negative, I'm going to factor out a negative 6. Look at my three terms. X squared is my greatest common factor. So I'm going to factor out a negative 6x squared. Negative 6 times what is 60? That's 10x squared. Plus, nope, not plus in this case. This case it's minus 19x plus 6 equals 0. Now, I guessing I probably can factor 10x squared minus 19x plus 6. Let's see if I can factor that using the Bob Schue method. Just because it's fun. So I'll go 10x squared plus 6. 10 times 6 is 60. So I'm looking for two numbers that multiply to 60 and add to a negative 19. Thinking ahead here already by what I wrote there. Negative 19, well, it'll be negative 15 and negative 4. Okay, well, if I take a look here, so that negative 6x squared, that doesn't go away. Look at the first two terms. What factors into both of those? Well, 5x does. And then I'll get 2x minus 3. Factor out the negative here, because the leading coefficient is negative. 4 and 6, 2 goes into those. And so factor out a negative 2, I get 2x minus 3. So this whole thing factors to negative 6x squared times 2x minus 3, because I factored the common factor out of both those terms, times 5x minus 2. So in the first case, I get negative 6x squared equals 0, or 2x minus 3 equals 0, or 5x minus 2 equals 0. And then in the first case, x equals 0. In the second case, if you can't use mental math, we'll go through it real quick. I'm going to add 3 to both sides. So 2x equals 3, divide both sides by 2. X equals 3 halves. Second case, I'm going to add 2 to both sides. 5x equals 2. Divide both sides by 5. X equals 2/5. So we get 2/5, 3 halves, and 0. And there we go. There are 3 answers. Now let's take a look at this next one. I think this next one, if I remember, I don't know if this is an interesting one or not, but we're going to do it because can't tell. So I look at all 3 terms. What goes in all 3? Well, 4 does. 4x. So I'm going to go 4x times what gives me 12x cubed. Well, that'll be 3x squared minus 4 times what is 11x plus 4 equals 0. Now this one I'm not going to use the Bob Schue method off the hand because there's only 2 numbers that multiply to 3x squared. That's 3x and x. Has to multiply to 4, but both are going to be negative, so I'm going to try, let's try negative 2 and negative 2. That'll be negative 6 minus 2. Doesn't work. Okay, let's try 4 and 1. So if I go, let's see here, 1 and 4, that'll be negative 12 minus 1. Oh, we run into a problem here, don't we? Does this factor at all? Well, let's check it. B squared minus 4ac. So that'll be b is negative 11 squared minus 4 times a, which is 3, times c, which is 4. So I get 121 minus 48. And 121 minus 48 is 73. That's not a perfect square, is it? So this one is not factorable. So if I'm going to go back up here, I can factor just the first step, but how in the heck do I solve a problem if I can't factor it? Oh, we got to use our favorite formula. First off, I'm going to say 4x equals 0, or 3x squared minus 11x plus 4 equals 0. First case, x equals 0, pretty obvious. Second case, not so obvious since it doesn't factor. We got to go x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so now let's substitute what we know. B is negative 11, so the 11 plus or minus the square root b squared, well, that'll be negative 11 squared minus 4 times 3 times 4 all over 2 times 3. So that becomes 11 plus or minus the square root of 121. Already did this, didn't I? Minus 48 all over 6. And the reason I said I already did that, in order to figure out if it factors, the radical, or the discriminant, was 73. So I get 11 plus or minus the square root of 73 all over 6. That's the exact answer. And of course, if I want to find the rounded answer, I can use my calculator and say x equals 11 plus the square root of 73 divided by 6, or x equals 11 minus the square root of 73 divided by 6. So if I go 11 plus the square root of 73, divide that answer by 6. If I round it to 2 decimal places, I get 3.26. And if I go 11 minus the square root of 73, I get 2.46. Oh, sorry, got to divide that by 6. I get 0.41. And so, can you find, yes, we have, don't forget, we have those fun ways of doing the quadratic formula. Quadratic formula always works if it's solvable. And number 19 was your guided practice problem, so I think we're sitting pretty good there. So these notes took a long